Okay, hi. Welcome back to the types of heuristics lessons. We are going to continue with our creative model drawing. Now, in our lesson objectives, we are going to recognize the concept of container and contents. And we are also going to learn to use model sharing, right, to visualize a problem. Now, what exactly is model sharing? Now, let's look at question number 1. Now, and once again, we have to highlight the keywords and the important numbers. Now, when 2,000 packets of black beans were placed into an empty wooden box of wooden crates, the total mass was 43.47 kg. When 40 packets of black beans were placed in the same empty wooden crates, the total mass became 70.25 kg. So find the mass of the wooden crates when it's empty. Okay, now, so how do we draw out this problem? Now, first of all, you need to highlight and read to understand the problem more clearly. So you can see that this problem is referring to a wooden crate, and inside the wooden crates, you are going to put some packets of black beans inside. So we are going to draw a model that is shared by the wooden crates and the packets of black beans. So this is how we do model sharing. Now, you can label like wooden crates, right? Let's call it the crates C, right? C for crates. And the packets of black beans, so let's call it, let's have a short form for packets, all right? Packets of black beans. So the crates and the packets of black beans, they will share a model, right? A rectangle, all right? So you draw a rectangle which represent the mass of the wooden crates and the packets of beans that you're going to put inside. Okay, so let's look at the first sentence. When 2,000 packets of black beans were placed into an empty wooden crate. So I'm going to cut the first part, and the first part refers to the mass of the empty wooden crates. So let's do some shading to show that it's the empty wooden crates, and the second part of the model will be the packets of black beans. Alright, so I'm going to put down 2,000. What is 2,000? 2,000 means that will be 12. Alright, 12 times 2, which is 24. Right, 24 packets of black beans. Okay, now to simplify the model, right, we can actually put the 24 packets of black beans into the box, right, into this part of the model. Alright, so that you can see more clearly later on. Alright. Now, and what is the mass of these crates and the 24 packets of black beans? The total mass, right, was 43.47 kg. Okay, so your 24 packets are like your units, all right, 24 units. But to make it more relevant, we call them 24 packets, right? We don't want to call it 24 units, so that it's easier to see. Okay, let's go on. When 40 packets of black beans were placed in the same wooden crates, the total mass became 70.25 kg. So I'm going to have model sharing again, the same crates plus some more packets of black beans, which is more packets now. So now you have a longer rectangle because the mass gets bigger. But the wooden crate is still the same. So I cut the same identical parts, which refers to the empty wooden crates. But this time you are going to put 40 packets of black beans into this empty wooden crates, right? So you put down 40 packets inside the box, inside the model. It is like your 40 units. Okay, all right. So what is the total mass of these empty wooden crates and the 40 packets? So the total mass is 70.25 kg. All right. So that's how you draw out the problem. And let's keep reading. So find the mass of the wooden crates when it's empty. So your model must have the question mark, and you can find the question mark which is in the shader box or the other shader box, which will still give you the same, right, the same answer. Okay, now the model is done already, right? So let's revise. Now you have 2,000 packets of black beans put into the empty wooden crates, and the total mass is 43.47 kg, right? And then when 40 packets of black beans were placed in the same empty wooden crates, the mass became bigger and the mass became 70.25 kg, right? So you can see that model sharing refers to what? Refers to two things, right, or even two persons sharing a rectangle, right? That's called model sharing. Okay, now, so how do we find the question mark? If your model is well done, you don't have to look at the problem. and you can work out the answer. So when you draw a model, always look for the difference. Right? So can you find the difference between the packets? So what's the difference in the packets? Now you have 40 minus 24 packets. Isn't that 16 packets? So there's a difference of 16 packets. Alright, so how heavy is 16 packets? Well, you can look at the whole rectangle, which is from here. Right, this is the total mass, right, of the crate and 40 packets, which is 70.25. And then you look at the total mass of the same crates, which is 24 packets, which is 43.47, and you find the difference. So which means that your 16 packets will be how heavy? 70.25, and you minus 43.47 kg. And you can use calculator, because at P5, most of these problems they are in the paper 2. So paper 2, when you do paper 2 exam, you are allowed to use the calculator. So 70.25 minus 43.47, 16 packets will be 26.78 kg, and it's like 16 units. All right, and now you find 1 packet. So 1 packet is also like 1 unit. So how heavy is 1 unit? So 26.78, and you divide by 16, and that will give you how much is 1 packet. Okay, let's work out 26.78 and divide by 16, and wow, you will get 1.67375 kg. Okay, which is quite a funny decimal. Okay, but let's keep working out, right? Because you may get the answer at the end, right? So don't get worried if you see a long decimal, and don't round off, right? Because if you round off, then the answer will become quite different. Okay, so can you find how heavy is the empty crates? So what do? Well, you just have to find how heavy is maybe 24 packets. So can you find 24 packets? So you times 24, alright, and beautiful, alright, see? And what do you get? Now, when you take your calculator and you want to find the mass of 24 packets, how do you do that? You take 1.67375, alright, 1.67375, and you multiply by 24, and you get back a very nice, decimal. Okay, let me just write nicely for you. So 1.67375 multiplied by 24, and you get 40.17 kg. Alright, so don't get panicky. Alright, don't panic if you see a funny decimal. Alright, and don't round off. Right, unless the question asks you to round off the final answer. Otherwise, you should not be rounding off your decimal. Alright, so now you can see that 24 packets of black beans is 40.17 kg. So can you find how heavy is the empty crates? You just look at the total mass, right, which is 43.47. Alright, 43.47 kg. That is the total mass, and you minus 40.17, and you will get the mass of the empty crates. So 43.47, and you minus 40.17, and you get 3.3 kg, which is the mass of the empty crates. And you solve the problem, right? And that's how you show model sharing. Alright, that's how you draw the model, which is like model sharing. Okay? Alright, now let's look at guided example 2, and let's revise. What is this model sharing about? Okay, let's look at example 2. Now you have a fraction. The mass of a box when it's half full of marbles is 3.6 kg. When another 0.6 kg of marbles is put into the box, it becomes 7/10 full. So find the mass of the empty box. Alright, so you can recognize that this problem has a container, and there is contents, which is the marbles that you are going to put inside the box. So we are going to draw model sharing. Alright, so again, you have a box that will share the model with marbles. Okay, let's call N for marbles. And we are going to draw a rectangle and cut the rectangle into two parts. The first part will be the mass of the empty box. And the second part will be the mass of the marbles, right? Which is half full of marbles. Now, half is like a fraction. Half is 1 over 2. So I'm going to put 1 over 2 into the second part of the model. So this half refers to half of the marbles. Okay, the box is half full of marbles. And the total mass is 3.6 kg. Okay, now keep reading. When another 0.6 kg of marbles is put into the box, it becomes 7 over 10 full. Alright, so what do? Now, it means that your mass has now become bigger because you put more marbles inside. Agree? So the rectangle will of course now have to be longer. Alright? And why longer? Because you put 0.6 kg of more marbles into the box. And same thing, I cut this part, which is the mass of the identical box. And this time, how much or how many marbles did I put into the box? Now, the box becomes 7 over 10 full. It means that you put 7 over 10 of the marbles into the box. So let me write as a fraction. Alright, so that is easier. Alright, you don't want to cut into many boxes. You can actually also indicate your fractions into your model. Alright, and the model is not done yet because where do you put 0.6 kg of marbles? Which is over here. Right, you put more marbles, which is another 0.6 kg of marbles. Okay, so can you find the mass of the empty box? So your question mark will be to find what is the shaded part. Alright, okay, now, so what do we do now? Now, when you draw a model, it's always, alright, when you draw a comparison model, always look for difference. Okay, look for the difference. For example, can you find the difference in the fractions? So you have 7 over 10 and you minus half. So what's the difference? So you have, you can use your calculator. So the difference is 2 over 10, right? 2 over 10. Okay? Or you can also do another something like this. You can actually make the denominator the same. Why would you want to make the denominator the same? Because we are referring to the same marbles. Alright, the same marbles that are put into the box. Okay, now, so you can make the denominator the same, or otherwise you just take 7 over 10 and you minus half, and the difference is 2 over 10. And isn't the difference also the same as 0.6 kg? So which means that 2 over 10 of the marbles, okay, is 0.6 kg. So can you find what is 1 over 10 of the marbles? How heavy is 1 over 10? So you take 0.6 and you divide by 2. So your 2 over 10 is like 2 units. 2 units of the marbles is 0.6 kg. Right? So you take 0.6 divided by 2 and that will be 0.3 kg. Alright, so can I find how heavy is 7 over 10? How heavy is 7 over 10 of the marbles? So 7 over 10 of the marbles is 0.3 times 7, alright? And you will get 2.1, right? 2.1 kg. And whatever numbers you found, you always put it into the model so that it becomes clearer. And then what is half? How heavy is half of the marbles? Okay, half of the marbles is, well, you can actually make the denominator to be the same, which is 5 over 10. So half is also 5 over 10 of the marbles. So how heavy is 5 over 10 of the marbles? 1 over 10 is 0.3. So 0.3 times 5. And that will be 1.5 kg. So half of the marbles is actually 1.5 kg. So now can you find the question mark? So how heavy is the empty box? So you take 3.6 and you minus 1.5 kg. And the mass of the empty box will be 2.1 kg. And you add on to your model. Okay? And there you go. So what is the mass of the box? Answer 2.1 kg. Okay? So that is called model sharing. Alright? when you draw a comparison model, so how do you continue to analyze your model? You always look for the difference, right? See whether can you do something about the difference. So model sharing means you have two kinds of things that share a rectangle. Alright, let's go on to practice problem, and let's see whether you can solve this by drawing out the model. So you have 10 minutes, right, to work out the problem, draw the problem first, and then use the model to help you to solve it. Alright, so you can pause the video, and when you have solved it, you can play the video again. Alright, so have you solved the problem? So let's highlight the keywords and the numbers. When the wooden box is completely filled with marbles of the same size, its mass is 37.1 kg. So you recognize that this problem has a container and has contents, right? The contents is the marbles. When it is 1/4 filled with marbles, its mass is 10.4 kg. So what is the total mass of the box and the marbles when it's 3/4 full? Okay, looks quite complicated. But once you recognize that this is a container and contents problem, then you draw model sharing, alright, something like model sharing. So you have wooden box share a model with the marbles. So you have a rectangle that represents the mass of the box and the marbles, cut it into two parts. The first part is the empty box, the mass of the empty box. The second part is the mass of the marbles. And it is completely filled with marbles, alright, so the box is full of marbles. And the total mass will be 37.1 kg. Alright, now when it's 1/4 filled with marbles, so it means that you have lesser marbles now, but still in the same box. And of course, the rectangle will become shorter because you have lesser marbles. And cut the rectangle into two parts, and the first part is identical because it's referring to the same empty box. And the second part will be 1/4 full of marbles. Okay? And what is the mass of this box, which is 1/4 full of marbles? The mass is 10.4 kg. Okay, let's go back to the longer rectangle. So what is full of marbles? What fraction is full of marbles? So the fraction will be 4/4, which is 1 whole. 1 whole means full, right? Full of marbles. Okay? Alright. Now, what is the total mass of the box and the marbles when it's 3/4 full? Alright, so we can't put the question mark here. Alright, so, but what we can do, we can find the mass of the empty box. So, how do we do that? We find the difference. So, can you look at the difference between the fractions? So, you can see that 4/4 minus 1/4, you get a difference of 3/4, right? 3/4. And what's the difference between the mass? So you take, so your 3/4, which is the difference, is also the same as what? You look at the total mass, right, which is 37.1, and you minus the total mass, right, of the box, which is 1/4 full of marbles, 10.4, and you find the difference. So 37.1 minus 10.4, and the difference is 26.7 kg. Alright, kg. Alright, so can you find how heavy is 1/4 of the marbles? So if 3/4 of the marbles is 26.7 kg, then 1/4 will be 26.7 and divide by 3. Alright, so 26.7 divided by 3, and you will get, alright, divide by 3, and you will get 8.7. Oh, sorry, 8.9. 8.9. So 1/4 of the marbles is 8.9 kg. Okay, then we can do plenty of things. So now I know that 1/4 of the marbles is 8.9 kg. Wow. So can I find the mass of the empty box? Yes, I can. So you take 10.4, right, 10.4 kg, which is the total mass of the box, that is 1/4 full of marbles, and minus away 8.9. Alright, so what do you have? So 10.4 minus 8.9, the mass of the empty box is 1.5 kg. Alright, so you got part of the answer. Alright, because you need to find the total mass of the box and the marbles when it's 3/4 full. So you already know the mass of the empty box. So how do you find 3/4? Oh, 3/4, that's quite easy because can you see 3/4 of the marbles? That is 26.7 kg, right? So what is the mass of the empty box? That is 3/4 full of marbles. So the empty box is 1.5 kg plus 3/4 of the marbles, which is 26.7 kg. And plus them together, and you get, so 1.5 plus 26.7, and you get 28.2 kg. Right? So that's how you solve the problem. And in this problem, in this model, we are unable to put the question mark onto the model because the question asks you to find the total mass that is 3/4 full of marbles, so we can't put a question mark. And if you can't put, then you don't try to put something that you can't put. Alright? Okay, so you have solved the problem. So indicate your answer at the bottom right corner. So what have we done for this lesson? Now we have done something called model sharing. So model sharing has to do with two kinds of things sharing a model. Alright, so when do you usually have model sharing? When you have container and contents kind of problems. Right, and how do you recognize this kind of problems? When you see a container that is filled with something else, alright, filled with water. Even water is also considered as contents. Or you have a box that is filled with maybe sand, so the sand will be the contents. Alright, so that's how you recognize container and contents kind of problems. Alright, in the next lesson, we are going to look at more creative drawing, right? More problems, and we are going to look at how to draw them out. Alright, when you draw them, you are not really solving, but you are trying to draw out the problems. The solving always comes later. Alright, so I'll see you in the next lesson.